All right. So, sig figs. This gave a lot of my friends some trouble, but I thought it's pretty easy. So, basically, a sig fig is a solution to a scientific problem. So, let's say you wanted to use pi, right? 3.14, right? This number is repeating. This number will go on forever and forever and forever and ever. So, if I wanted to use pi in any scientific way, it would be really hard for me to do that because maybe some scientists would use it to the fourth decimal, and I could use it to the eighth decimal. So the problem is that if I wanted to multiply 3.14, this constant number, by like 2, if someone were to use 7 decimal places, their number would be slightly different to mine, where I use 2. So I would get like 6.28. And then this other person would get, I don't know, like 6.34216. That's completely BS. But for example, these numbers are different. And in a scientific setting, this is really bad because if you had 6.34216 grams of, I don't know, Tylenol, or like, not Tylenol, that's like simple, like a really like dangerous drug that if you take too much of, you could die. This is a problem because if you take too much of this, you're gone. And this is the right amount? Well, sure. So sig figs is a solution to that rule. This is just a way of tracking how many decimals or how many numbers you're keeping track of at each time. So there's some rules. The first rule is non-zero digits are significant. So, for example, if I have the number 1, 2, 3, 4, 5, 6, we're going to have 1, 2, 3, 4, 5, 6 significant figures, since all of these numbers are significant, and they're all non-zero. So now let's say we had 1, 2, 3, like 0, 1, 2, 3, 4, 5, 6. We would still have 6 significant figures because 0 is not a non-zero number. So now, the second rule. Any zeros between 2 sig figs equal significant. So, let's go back to 1, 2, 3, 4, 5, 6 number. Example, sorry. 1, 2, 3, 0, 4, 5, 6. So in this number, we're going to have 7 significant figures because there are 6 non-zero digits and there's 1 0 that's between 2 significant digits, which is the 0 between the 3 and the 4. Therefore, we have 7. Now the final rule, I don't know if I can squeeze this in, is that a final 0 or trailing 0 only are significant in the decimal portion, sorry. So a final 0, okay, I'm going to have to redo this part. God damn it. So the third and fourth rule, they kind of go hand in hand, is that a final 0 and trailing zeros are only significant when they are in the decimal portion. Equals sig when. For example, let's say we have the number 0.500. So, this is the trailing 0, these two zeros. However, since this is a trailing 0 in the decimal section, we consider a significant figure. This is because we know that we have 0.500, so we are certain that we have this much to the thousandth decimal point. This is useful. But this isn't useful if you have something like 003150, right? because this doesn't tell us anything. These two don't tell us anything. Therefore, there's only 4 sig figs here. Or are there 3? Well, I think there's 4. I'm pretty sure there's 4. Anyway, another example, this kind of combines everything together, is like 35.40500. How many significant figures does this have? Well, there are 1, 2, 3, 4, 5, 6, 7. There are 1, 2, 3, 4 non-zero digits. There's one digit that is between 2 significant digits, and there are 2 trailing zeros that are in the decimal section. An example of a final zero or trailing zero that is not significant is something like 0.006. Now these 2 digits are not significant because they don't tell us anything. This number is significant because we only know, the only thing that matters here is that we have 6 thousandths. I think that's, 6 thousandths. These 2 don't tell us anything, therefore they are not considered significant. Okay, and one more thing before I get into like operations. Saying 0.1 or just 0.1 doesn't make any difference in terms of sig figs. This 0 is not considered a significant figure. Therefore, in this number, there's only 1 sig fig. Okay, so for addition and subtraction, there's different, you use the same method, but for multiplication and division, it's different. So the first step, let me get an example. 315 plus, actually no, 315.420 plus like 52.60. So the first step is to count the number of sig figs in the decimal portion only. Of each number. So for 315, we have 3 sig figs on the decimal portion, and for 52.60, we have 2 as well. We have 2. And then the next thing is that you just add or subtract. Same thing. No, nothing different there. So then we would have 367. Wait, no, we would have 368.020. This is without accounting for sig figs just yet. And let me just make that more readable. Okay. Third step. There should be no more sig figs than the number of sig figs in the least, the number with the least amount of sig figs. So therefore you would use the amount of sig figs in 52.60 since there's 2 compared to 3. So then you would say that there are 2 here, so you would just get rid of the 0, and you have 368.02. Alright. Okay, so now for multiplication and division. So both of these work the same way, multiplication and division. However, they do work a little bit differently from addition and subtraction. So basically what you would do is the same thing. You would look for the number with the least amount of sig figs. So like, let's say we have 0.012 times 0.145. Sure. So we can recognize that 0.012 only has two significant figures, and then 0.145 has three significant figures. So we recognize that this one has the least amount. So then we're going to multiply it as usual. Let me just see. So you would have an answer of 0.00174. This is before we adjust for sig figs. So then you're going to look for the number. Then you're going to round to the number of sig figs that were the smallest number. So we have 0.012, so we're going to have two sig figs, 0.0017. And 4 is not equal to or larger than 5, so you don't round up, you round down. Now, multiplication and division are kind of different because you would also take into account numbers outside of the decimal proportion. So let's say we had 15.12 times 14.9. Well, we can recognize that this has 3 and this is 4. Therefore, we're going to be taking into account 3 sig figs instead of 4. So if we multiply them, we'll have 225.288. Excuse me. So now we have 3 sig figs. So we're going to round to 3 sig figs. So we're going to basically just cut out the decimal. So this is your answer then. And yeah, that's sig figs.